So let's talk about the comparison part for the linear acceleration rides, right? What we want to do is we want to compare the accelerations we get from the video analysis to the accelerations that we read with the cell phone data. Okay, so it's just basic concept here, right? Is that if we're sitting on a ride and it doesn't accelerate, then what the thing is going to read, the acceleration, is just going to be, it's going to be as if we were accelerating upward at 9.8 meters per second squared. Okay, so if you just hold your phone and you're using the acceleration with g, it's just going to read 9.8, or it should, meters per second squared. Now, if the ride itself accelerates up or down, okay, then what you're going to read is 9.8 plus the ride in both cases, right? So when it's accelerating up, it's a positive acceleration, and you'll get more than 9.8 meters per second squared reading on your accelerometers. And when it accelerates down, it's going to be less than 9.8 meters per second squared on your accelerometers, okay? So let's just take a look at these things. So the first thing you're going to do is ride the ride, get the data, right? Then the next thing is get a video of the ride. And what we do from that, right, is, and you know this, we're well rehearsed, is we know that the acceleration is 2 times that, whatever that coefficient is. So 2 times 3.617. And here it's the downward acceleration is 2 times negative 2.329. Okay. And this is going to be around 7.2. And this is going to be around negative 4.6, right? So then the question is, does our data kind of match that, right? So let's just take a look. This is actual frog hopper data, right? Okay. And we thought that we'd accelerate down at about 4.6. So here's kind of our downward acceleration, right? So this is kind of 9.8-ish here. Okay. This is when we're accelerating down. So this is 9.8 minus 4.6. Does that seem to match? What is that? Can we do this? I need my calculator. 9.8 minus 4.6 is approximately 5.2, right? And it's not a great. Here's 5, right? And it looks like it's even a bigger acceleration than that. But see, here's the thing. Do you see how I selected this? If you make a narrow selection, this acceleration is not uniform. So if you make a narrower selection, sometimes you'll get bigger accelerations. Okay, but that's what we're comparing, right? Okay, and then these upward accelerations, we figured out that was accelerating up at about 7.2 roughly, right? Okay, well, so that means here, this stuff here should be 9.8 plus 7.2. Well, that's 17, right? Are we close to 17? Yeah, sure. Here's 17. 17's right in the ballpark. It seems to be bigger than that, though, right? But these smaller accelerations are like that. Keep in mind that there's a range of accelerations. So the first one's not so big. The next one's bigger. The next one's really big, right? And so the first one, the next one's really big, right? And I don't know which one you look at, right? So anyway, so just that's how you do that. And these are the vertical ones. If you're looking at and the spider data is going to look like this. So the spider is somewhat more, let's just say somewhat more aggressive. Okay, whereas this approaches 20 meters per second, the spider generally exceeds that. Okay, but actually fairly similar, right? You wouldn't think the spider and the frog hopper would be comparable, but of course the spider's got the spin too, right? Now for the scrambler, you're going to do some video analysis, and here notice that we're using the X. Okay, so this is an X acceleration, and notice it's pretty big. I got a pretty big acceleration. Remember, it's twice that, right? So basically, it's about 14 meters per second squared is our sideways acceleration. That's basically what 1.5 times your own weight sideways exerted on you, right? It's a fun ride. Okay, and then sure enough, take a look at this. This is about 1.5 times your weight. Okay, so notice that the accelerations we read are actually pretty similar to that, right? We get a pretty big acceleration. Notice that we also get an acceleration the other way too. Right, and you can see the ride speeds up, goes to constant speed, then it kind of slows down like that. Okay, so for the scrambler, it's actually pretty simple. Once you figure out the video analysis of it, right? Once you figure out this part, And notice I made a fairly narrow selection from here to here. It doesn't match this data so well. And that could just be a parallax error. That is, it's kind of coming toward you and going away from you. But anyway, so that comparison is just a direct comparison. Since it's horizontal, we don't need to worry about the acceleration of gravity.